Hello, my dear friends. Today's topic is statistics. Statistics is actually a part of applied mathematics. There are actually two main branches of mathematics, your applied mathematics and pure mathematics. Pure mathematics deals with theoretical part, theorems and everything, and your applied mathematics deals with the application of the practical knowledge you have. This is actually statistics is a part of applied mathematics. So let's explore it and see what interesting things are hidden inside. What topics we are going to cover in this video? The topics will include introduction and definition of statistics, steps of statistics, data and its types, collection of data, representation of data, what are they, then measures of central tendency, that is mean, median, mode, and your measures of dispersion, that is range, quartile deviation, mean deviation and standard deviation. So these are the topics to be covered in this video. So let's see what is the definition. First of all, it is actually science of collecting and analyzing numerical data in large quantities. As I have told you, first of all, it is a part of applied mathematics. That means the mathematics which we can apply in our daily life, in our practical use, right? And actually it is a science of collecting the numerical data. Means you have to collect the data and then you have to analyze as well to find out the results, and that too in large quantities. If your data is given in large quantities, this particular field of mathematics is used to find out the results, right? There are two types of statistics, descriptive and inferential. Descriptive means it is just a description of a data. Means it just helps us to simplify the large amount of data in a sensible way or readable way, or you can say in simple language, a simple summary of the data, right? And for example, you calculate the mean, median, mode, skewness, kurtosis, all these are just to summarize the data, right? And inferential means to deduce from a given sample. Means it actually allows you to make predictions or take out the results from that data. So actually you take the data from the samples and make a generalization about the population. For example, if you are taking a data of 100 people and you are actually finding out the results on that data, and then you can apply that in the larger population as well. So for example, you are calculating the weight of 10 people and then you are generalizing that, right? So that is just inferential, means you are actually finding out the results. There are various fields in which this statistics is used, and for example, it is in psychology, geology, sociology, weather forecasting as well, probability, etc., etc. There are so many fields, and it is a very, very, very important field of study. First of all, what are the steps in statistics? Steps means how you're going to handle the data. You have to follow certain steps, right? First of all, it is collection of data. First, you need to collect the data. The collection is done from various sources, so you have to collect that data. Secondly, once you collect that data, then you have to organize that data. So second step is organization of data. So you have to organize that data in a proper form, in a readable form, right? Next step is analysis of data. Analysis of data means you have to analyze that form now. You have made a proper presentation of that form. Then you have to analyze that data, means what the data is actually about. The last step is inference or drawing conclusion. Means whatever you analyze from that data, you have to draw conclusions, you have to find out the results, you have to take out the information what the data is talking about, right? So that means the results. So these are the four steps you will manage the data. First of all, you collect the data, then you organize it, then you analyze it, and you then conclude what actually the data is about, what information we can get out of the data. Next is data and its types. What is a data? I told you data is just the numerical sample. Okay, So that has a certain meaning to collect. We have a certain motive of collecting that data. So that is actually data, numerical values. Next, what are its types? There are two types of data, that is quantitative and qualitative. As the word says, quantitative means there is a numbers involved, right? So numerical data is called quantitative, and qualitative means it is telling about the quality of data, obviously categorical. Okay, so that means the quality, what qualities are there in the data, that is means if the data is in the numerical form, so it is quantitative. It is not in the numerical form, then it is qualitative. And they are subdivided in the two parts. Quantitative data can be discrete or continuous. Discrete means you have a separate values, means which cannot be further broken down in intervals or units, right? And continuous means that values which can be further be divided or broken down in units or intervals, right? And qualitative, on the other hand, has two types, nominal and ordinal. Nominal means you don't have any order, like you are saying he's a male or a female. So there is no order. No one is bigger than the other, right? So there is actually no order, means, or you can say an eye color of the eye. So that doesn't have any order, blue, green, yellow, right? So that their order doesn't matter. So that is nominal. And ordinal means where they are ordered, means, for example, I have given you, like you have an order that cold, then after that it is warm, then after that it is hot, and then it is very hot. So there is certain order you are following, right? So that is called ordinal, right? Next is collection of data. Now you have to collect the data. First step in your statistics. How you're going to do that? You have to do that in either of the ways, either primary data or secondary data. Primary means you are directly yourself collecting the data, and secondary means you are indirectly getting the data. For example, I can give you, for example, you actually are measuring the height of the students in the class and you are writing down that in your notebook. So you are collecting 50 students' height by actually yourself measuring the heights of the students, right? And secondary means you are just taking the help of the class teacher register for getting the heights of the kids. So the class teacher have done the task of collecting the height, so you're just copying it in your register. So that is secondary. So you indirectly got the heights. And primary means you are yourself measuring the heights. So that are primary and secondary data. Next is representation of data. Representation of data. Data can be represented or organized, you can say, in following manners. You can draw a bar graph or a pie chart or line graph or pictograph or histogram or frequency distribution table. So any of these are used to actually represent or organize the data in the proper form, right? Readable form. Okay, so what is measures of central tendency? As the name suggests, it is a measure which is actually placed centrally. What is it? Let's see. It is a single number that denotes the center of the set of the given data. So it is actually the number which is denoting the center of the set of a given data actually arranged in a proper form, right? I'll tell you with an example with this. Let's see an example. Example says the weight of 10 students in a class. I'm taking the weight in kgs. So let's see if I have weight of 10 students in a class. So they are arranged like this. Firstly, whatever question you are asked in the exam, you just need to arrange that in ascending order. That is the very first step you are going to do in any of the question, right? So just remember, whatever question of statistics comes, just arrange that in ascending order. That will be much easier to actually grasp that question and to find the numbers, right? Now let's see. If I arrange this in an ascending order, it is placed like this, right? There are 10 numbers in total, right? So let's see. There are actually main three measures of central tendency. First is mean. What is mean? The other name for mean is average. So average actually means, as you always calculate the averages is just sum of the numbers in the numerator divided by the total number. Right, so if I have these 10 numbers, that means my total numbers are 10, and I have to sum the numbers in the numerator, right? So this is the formula for it: x1 plus x2 plus up to xn divided by n. That means I am adding all the numbers in the numerator and I am actually dividing it by 10, that is total numbers. So if I do that, I'll get the answer 422 by 10. That comes out to be 42.2. That is the mean or an average of the given data. Right? Now, second measure of central tendency is actually median. So what is median? Median is a middle number. Median is actually a middle number when the numbers are arranged in a ascending order. So actually I have arranged the numbers in the ascending order already. So mean is actually the middle number. Middle number means if you divide this whole series, or you can say numbers, into equal halves, the middlemost number will be the median. Now median, if I have to find out out of even odd numbers, that will be easier. How? If you have 11 numbers in total, right? So what you will do is you will keep 5 numbers on the left side, 5 numbers on the right side, and the middle one will be your median. That will be much easier if you have odd numbers. But if you have even numbers, what you will do, you will take the mean of the middle two numbers. Means you will find out the middlemost two numbers and you take the averages of that. Here you can see I have 10 numbers in total. That means even number, right? So if I count, I will find that 43 and 44 here, 43 and 44 are the numbers which are the middlemost. So I will take the mean of these two numbers. So mean will be 43 plus 44 divided by 2. So that will be 43.5, right? The third measure of central tendency is mod. Mod is very simple. The number that occurs more frequently. Means if the number occurs maximum number of times in the given numbers, that number will be the mod. So here you can see that 44 is actually coming 3 times and the other numbers are coming 2 or 1 time, right? So 44 is actually coming maximum number of times in the given data. So therefore 44 is our mod. Means that. Now next is why measure of dispersion. Now the question arises that actually we have measures of central tendency, right? So statistics can be done through that, but why there is a need to get these measures of dispersions as well? Why we got the need of doing this as well? So the reason behind it is, if you will see, I have taken an example, marks scored by 10 students in a class out of 100. So there is 2 tests, test 1 and test 2. So I have been given marks of 10 students out of 100 in 2 exam tests. And if you calculate the mean of test 1 and the mean of test 2, so we'll find that both the means are coming out to be same, that is 49, right? But if you observe it very deeply, you will see that the first graph, if you plot of test 1, you will see that the data is very much scattered. Means there is 35, there is 93 as well, there is 14 as well. So data is very much scattered here and there, right? But if you see the graph of test 2, you will see the data is more between 35 and 60. It is between 35 and 60, but that is more arranged in a fixed, means in some particular place. But here in the first test, the data is much scattered, right? It is between 0 to 100. It is very much scattered, right? So, but the mean is coming out to be same. So that means mean is coming same, but we don't get an idea that the numbers might be scattered or not. So this idea is actually given by measures of dispersion. It tells you that how dispersed or how scattered the data is. So how you are going to actually test that, I will tell you in the next slide. Now we will see the measures of dispersion. There are actually main four, you can say 5 measures of dispersion, right? So 5 measures of dispersion, one is actually a part of the other only, so mainly 4. So what is measure of dispersion? As I told you, it gives you an idea how dispersed or spread out your data values are. So it tells you about this. So if I take an example like 25, 67, 48, 53, 18, 39 and 44. These are 7 numbers and I have to find the measures of dispersion. So they are actually one by one. I'll tell you the measures of dispersion and I will tell you how you're going to calculate it as well, right? So first of all, very first step is arranging them in the ascending order, as I told you in the last videos. So just arrange that in ascending order. Now our first measure of dispersion is range. Range, you can, by the name you can tell that range means difference between the highest and the lowest values of the given data. Means the number which is maximum and the number which is minimum, that you have to find out and you have to subtract that. So maximum number in this data you can see is 67 and minimum number is 18. So you have to subtract both the numbers, you will get the range 49, right? That is very simple. Second measure of dispersion is quartile deviation. That is very, very, very important. Quartile deviation. Quartile, as the name suggests, means fourth part, right? So if you see this line, if you have this data arranged like this, so this line actually represents the data, right? The middlemost point, the yellow point, is actually Q2. I am denoting the points by Q1, Q2, Q3. Right? Q2 is actually the middlemost point. Means Q2 is actually, if you see very deeply, you will see that Q2 is actually dividing the data in 2 equal halves. Right? The first half on the left side and the second half on the right side. So this Q2 is actually, we can say, median, as I've studied in the last slide. Median is what? Median is a central data point which divides the whole data in 2 equal halves. So this Q2 is doing the same thing. It is dividing the data in 2 equal halves, right? And Q1 is actually between the first data and Q2. Midpoint of first data, beginning of the data, and Q2. And Q3 is the midpoint of Q2 and the last point of the data, right? So this 3 points are actually dividing the whole data in 4 equal parts. That means quartiles, 4 quartiles. First quartile is Q1, second quartile is Q2, and third quartile means Q3. So these 3 are 3 quartiles, which are actually dividing the data in 4 equal parts, right? So Q is interquartile range. Q is called interquartile range, and the formula is half Q3 minus Q1. That means you have to find out Q3, you have to find out Q1, and you have to subtract that and divide by 2. So that will give you interquartile range of the quartile, right? So how you're going to find it out? Let's see by an example. So I am taking the example of this numbers. There are 11 numbers. So let's see. This comes the table. Table is actually, I have made a table, serial number, then the data, that is X, then the third is median, and the fourth is quartile. Now, serial numbers, there are 11 numbers in total. X means the values, the numbers. Actually, the numbers are 6, 6, 25, 25, 47, 76, 109, 112, 112, 150, and 167. Right? Now, if you have to find the median, median means the centermost point. How you find the median? you will divide the data in 2 equal halves. That means the formula you have studied in your 8 classes, that is n plus 1 by 2. Means if you have an odd number of data, here it is 11, so odd number of data, you have to use the formula n plus 1 by 2, that is 11 plus 1 by 2, that is 12 by 2, that will come out to be 6th place. 6 is actually the place. So you will see that here the 6th place is this, and the number in the 6th place is 76. So the median will be 76, right? Similarly, the quartile. Quartile means first quartile. First quartile, the formula is same. If you have odd numbers, you have to divide by 4 because you have to find the 4th part. So it is n plus 1 by 4, right? So n plus 1 by 4 if you'll do, so 11 plus 1 by 4, that is 12 by 4, that is 3rd place. So you can see the 3rd place is actually 25. 3rd place is occupied by the number 25. So 25 is your first quartile, right? And similarly, the 3rd quartile, the formula is 3 into n plus 1 by 2, means the 3rd one, right? So n plus 1 by 4 into 3, right? So into 3 if you'll do, so you will have 9th place, and you can see the 9th place, the number is 112. So 112 will be your 3rd quartile. And if you have to find the interquartile range, that is the formula Q3 minus Q1, that is 112 minus 25, that is 87. And you will divide it by 2. Okay, so next is 3rd measure of dispersion, that is your mean deviation. What is mean deviation? It is deviation from the mean, as the name suggests. How much the data points are deviated from the mean point. And the formula is 1 by n summation xi minus the mean y bar. The 4th one is standard deviation. It describes the difference between the data value and the mean. I will tell you by an example once I gave you the formulas, right? And the 5th one is variance, that is the square of standard deviation. If you square the standard deviation, you will get the variance, right? So let's see by an example. Example is, I have taken very simple example, 5 numbers, 4, 7, 8, 10, 11, right? Now, if I make the table for this, why I need to make a table? Because I need to find, first of all, if you can see the formula, it is xi minus y bar. Y bar is the mean, and xi's are the points of the data. So I have to calculate xi minus y bar whole square first of all, and then I have to add them. So I will find it with the help of a table. It will be very simpler. Xi's are the points, as you can see in the first column of the table, that are 4, 7, 8, 10 and 11. And xi minus y bar, the second column, if we'll calculate, how you can to calculate? First you need to calculate the mean, that is y bar. In the 4th column you can see mean is calculated by adding the numbers and dividing by the total number. So if you add all the numbers, you will get 40. 4 plus 7 plus 8 plus 10 plus 11, that comes out to be 40. Divided by 5 is 8. So you can see the red big 8. So 8 is actually the mean of the data. So what you need to do is, you have to subtract this mean from each of the point of the data. That means the first point is 4. So you have to subtract 4 minus 8, that comes out to be minus 4. So xi minus y bar will get you all the answers. So now 7 minus 8 is minus 1, 8 minus 8 is 0, 10 minus 8 is 2, 11 minus 8 is 3. So if you add these, you will get the sum as 0, pink 0, right? Now you have to square them. So just make the whole squares of them. So minus 4 whole square is 16, minus 1 whole square is 1, 0 square is 0, 2 square is 4, 3 square is 9. And you add all of them, you will get 30. So xi minus y bar whole square summation. Summation means your sum. Sum of the numbers is coming out to be 30. Right? Now if you will arrange that in the formula, your standard deviation says under root 1 by n into summation of this. Summation is coming out to be 30 and 1 by n. N is a total number. Total number is 5. So if you divide 30 by 5, it comes out to be 6 and it is in the under root. So it is under root 6 is the standard deviation. And variance will be the square of standard deviation. So under root 6 whole square will be 6. So variance will be 6. And what about the mean deviation? Mean deviation, the formula says summation xi minus y bar. So xi minus y bar, if you see in the table, the second column, it comes out to be 0. Right? So if we'll divide 0 by 5, so it will be 0 only. So mean deviation here is 0. That means the points are not much deviated from the mean. Right? So that mean deviation is 0. Much more and group data examples will be coming in the next video. So please keep sharing and do like. Press the like button if you like the video, share it and subscribe the channel for the upcoming videos. Thank you very much.